All right, section 11.2, operations, just basically means adding and subtracting. And we've talked about on several occasions how we treat radicals a lot like we treat variables, and that is the exact same way that we do this when we're adding or subtracting. Think about like terms with variables, 3x plus 2x. Those are alike because the x's are the same. They're both x's and they're both to the first power. That's what makes those like terms. So the way we would combine them is we add the numbers in front, 3 plus 2, which gives us 5, and the x is still just x. We leave it alone. It had to be the same in order to add them, and it stays the same when you're done. Those exact same rules are what applies to square roots. If this expression instead would have said 3 radical 5 plus 2 radical 5, we would have said, okay, the square roots match. They're the same, which means I can add them together. And I'd add the coefficients or the numbers in front. 3 plus 2 is 5. And I would leave the square root alone. It had to be the same in order to add them, and it stays the same when I'm done. So instead of 5x like I used to have, now I have 5 root 5 because this, I have a square root instead. They have to be the same in order to add them together, and they stay the same when you're done. Keep in mind, if the square root is not simplified, you don't know if you can add or subtract them. So you have to make sure the square root's simplified first. So treat them like they're variables. You can only add and subtract them when the same number's under the square root. And whatever you do, you add or subtract the numbers in front and leave the root alone. So, just like we did way back when, go to each term, 4 radical 3. Underline it once. Go to the next term. 6 radical 3 matches 4 radical 3 because the square root is the same. Then go to the next one. 5 radical 3 matches all of those because it's also square root of 3. So add or subtract the numbers in front. 4 plus 6 is 10, minus 5 is 5. The square roots had to be the same in order to add and subtract them. Stays the same when you're done. Final answer, 5 root 3. On the next one, we have 4 radical 5 and 9 radical 7. Radical 7 doesn't match radical 5, and they're both as simplified as possible. 5 can't get split up and 7 can't get split up. So that's as good as that's going to get. So that's the answer. It's just the exact same thing. You couldn't add any of them together. It'd be saying like 4x plus 9y. You can't do it because they don't match. So they just stay like that. Go to the next one. Radical 5, radical 5, radical 5. You can put all of them together. So 6 plus 2 is 8, minus 5 is 3, and the root stays the same. If you don't simplify your roots first, you can't assume that they aren't going to work. Like right now, you'd look and say, oh, 8, 32, they don't match, so I'm done. That's not true because you have to be able to split them up first. I'm going to rewrite this a little bigger. If you look at 8, you say, okay, 8 itself is not a perfect square, but it is divisible by 4. So you have to split it up. The 5 is still on the outside. 8 splits into radical 4 times radical 2. Radical 4 comes out as a perfect square of 2. And this 2 stays inside. Just like what we did in the very first day, multiply the numbers on the outside, leave the square root alone. Move on over and do the exact same thing to the 32. This 2 is on the outside. 32 is divisible by 16 and 2. 16 comes out as a 4. 2 stays inside. 2 times 4 gives me 8. Radical 2. Once I've simplified everything, I just keep the sign whatever was in the middle, in between, which was addition. And now I can see that now they match. So 10 plus 8 is 18. And the square root of 2 stays the same because they were the same, and so they keep it the same. So this one had to be broken up before I could decide if they could be put together. We'll just do a couple of these. 20 goes to 4 and 5. 4 comes out as a 2, gets multiplied by the 2 already out there. So 2 times 2 is 4, radical 5. Plus 45 goes to 9 and 5. 9 comes out as a 3, gets multiplied by the 3 already out there, giving me 9 root 5. And 180 gets divisible by 36. And 5. 36 comes out as 6. There wasn't anything out there, so that's now the only thing, and 5. Now that I've simplified all of them, I see they're all radical 5s. So 4 plus 9 is 13. Minus 6 gives me 7. The radical 5 stays the same. And we'll do the bottom one. 27 goes to 9 and 3. The 9 comes out as a 3 and gets multiplied by the 6. So 18 root 3. 12 goes to 4 and 3. The 4 comes out as a 2, gets multiplied by the 8. 8 times 2 is 16, and the 3 is still in there. 75 goes to 25 and 3. 25 comes out as 5 times the 2, 10 root 3. Now they're all radical 3, which they're not necessarily all going to be the same at this point, but if any of them are the same, then you put the ones together that are. So we just add or subtract the numbers in front. So 18 plus 16 plus 10, which gives me 44, and the radical 3 stays the same. But again, they had to be simplified before I could make any decisions on whether or not they could be put together. Alright, and the second assignment of the day is page 595, 14 through 24 even.